We need to show that the derivative of y with respect to x is given by negative of square root of 1 minus x squared divided by square root of 1 minus x squared. Here we are given an equation in its implicit form. So let's begin with the given equation. So here we have y times square root of 1 minus x squared added to x times square root of 1 minus y squared. So this value is equals to 1. So let's label this as number 1. So what we'll do, before taking the derivative on both sides, we'll try to simplify this given expression. We can make a trigonometric transformation here. So let's substitute the value of x with cosine of a, and we'll substitute y with cosine of b. When you substitute y with cosine of b, we get cosine of b multiplied to square root of 1 minus x squared. So that gives us cosine squared a plus x. So x here is cosine of a multiplied to square root of 1 minus cosine squared b. So this value is equals to 1. So that gives us cosine of b times square root of, so we have 1 minus cosine squared a. So this is sine squared a plus cosine of a multiplied to square root of sine squared b, which will be equals to 1. Now cosine of a times square root of sine squared a will be sine of a plus cosine of a times square root of sine squared b will be sine b. So this is equals to 1. Now what we can do, we can combine this. We have an identity here. So this is the sum of the angles given by sine of a plus b. So this will be equals to 1. Now what we'll do, we'll take the inverse sine function on both sides. That gives us a plus b equals to sine inverse of 1. Now what we'll have, we considered x to be equals to cosine of a. So that means a must be equals to cosine inverse of x, and b must be equals to cosine inverse of y. Right. So let's substitute this in place of a and b. Now we have cosine inverse of x plus cosine inverse of y. So that will be equals to sine inverse of 1. So what we've done, by making this to trigonometric substitution, we have converted our original implicit equation into this new inverse trig equation. Now what we'll do, we'll take the derivative on both sides with respect to x. We have derivative with respect to x of cosine inverse of x plus derivative with respect to y, x of cosine inverse of y will be equals to the derivative with respect to x of sine inverse of 1. And we know that when we have derivative with respect to u of the inverse cosine function, cosine inverse of u, that's given by negative 1 divided by square root of 1 minus u squared. So let's use this formula. Now the derivative of cosine inverse of x will be negative 1 divided by square root of 1 minus x squared plus derivative of the inverse cosine function will be negative 1 divided by square root of 1 minus y squared. But here we have y, so we will need to multiply it to derivative of y with respect to x. We have used the chain rule here. And sine inverse of 1, that's a constant, so this will be simply 0. Now we will transpose negative 1 over square root of 1 minus x squared to the right hand side. So that gives us negative 1 divided by 1 square root of 1 minus y squared times derivative of y with respect to x. That will be equals to 1 divided by square root of 1 minus x squared. Finally, we get derivative of y with respect to x as given by negative times square root of 1 minus y squared divided by square root of 1 minus x squared. So this is what we are asked to prove.